Hey guys, in today's video I will show you why you should love a factor theorem. Say you have a polynomial x to the fourth power plus x cubed minus x squared minus 1, and you need to show that monomial, let's say x minus 1, is a factor of this polynomial. Well, to be perfectly honest with you, there are different ways to show that. You could either use the long division and divide this polynomial by this monomial x minus 1, or you could use the synthetic division. It perfectly fits into synthetic division since you are given your monomial in the form of x minus a. Now, there is another shortcut that basically gonna beat all of these two methods, all of these techniques, and it's called by using the factor theorem. And all it says, generally speaking, if you are given a polynomial, let's call it p of x, any polynomial. And if you are given another monomial, let's say x minus t, if this monomial x minus t is a factor of this polynomial, then p of t is gonna be equal to 0. So in other words, t is gonna be the root of this polynomial. The inverse statement is also true. So if p of t equals 0 for some t, so t is a number, then x minus t is gonna be the factor of this polynomial p of x. In other words, x minus t, this monomial goes evenly, fits evenly into this polynomial. Now, let's put it to the test. So you are given the polynomial to the fourth degree, to be precise, and you are given this monomial x minus 1. All you do, you take 1, you kind of read off and pull out 1 from this monomial, since you need to take the opposite, the inverse. So it's going to be 1. And you are going to substitute this 1 into that polynomial everywhere x appears into. So we have 3 places, 3 spots to be precise. So in other words, you need to find p of 1. So you just do this plug-in or substitution, and it's gonna be just piece of cake. So it becomes 1 to the fourth power plus 1 cubed minus 1 squared minus 1. All you need to do is just prove that that equals 0. So let's check to see. So 1 plus 1 becomes 2. So 1 to the 4, 1 to any power is just 1. So minus 2, it does equal 0. So that means, that implies that x minus 1 is going to be a factor of this given polynomial. Alright, now if you know this fact, you can use it in any ways. And by the way, I do have a separate videos also on polynomials, for the remainder theorem, for solving cubic equations. And if you are down to these things, feel free, all these links would be down below in the description box. Go ahead and check them out. Now, what if you are given not monomial in the form of x plus or minus a, if you have the coefficient in front of x is not equal to 1, something like 3x, 2x, 5x, or it could be negative 10x or whatever number. So extended version of the factor theorem kicks in. So say you have been given this polynomial 3x cubed plus 4x squared plus 5x minus 6, and you need to prove, you need to show that this monomial 3x minus 2 is a factor of this polynomial. First of all, that might come to your mind is just straightforward long division, old-fashioned long division. And unfortunately, at this point, you cannot use the synthetic division, since your coefficient in front of x is not equal to 1. Besides the long division, the extended theorem, the extended factor theorem can be used. All it says, generally speaking, if you are given the polynomial, let's call it P of x, and now if this polynomial P of x has the monomial, let's say tx minus s is a factor, then P of s over t equals 0. Basically, all it says, you need to take this s over t and kind of make up this fraction that again comes from these numbers, this coefficient and this constant term. And you need to prove, you need to substitute, you need to plug in into your polynomial everywhere x appears and check to see if it equals to 0. So if it does, that means, that implies your monomial is a factor of this polynomial, so it goes into your polynomial evenly, it fits evenly. Let's put it to the test. So all you do is just match up. So your t is gonna be 3 and your s is gonna be 2. And look at this, you need to switch the signs. So if it were minus here it has to be plus, and vice versa. This is your t, 3, and this is your s. So I'm going to take 2 over 3 from that polynomial, so from that monomial to be precise, and I'm going to plug in into x, everywhere x appears in my polynomial. Let's just denote this polynomial by P of x or any letter you wish you like, and all you do is just find the value P of 2 over 3. So substitute, you keep this 3, 2 over 3 cubed plus 4, 2 over 3 raised to the second power, plus 5, this coefficient in front of x, times 2 over 3, and you need to subtract this constant 6. So you need to do this math, and remember, when you have a fraction and when you raise a fraction to a power, basically all you do, you just raise separated top and bottom to this power. It becomes, you want to keep this 3 for now, 2 to the third power, it becomes 8 over 3 to the third power, 27, plus 4, 2 squared becomes 4 over 9, 3 squared, plus 5 times 2 gives you 10 over 3, minus 6. So 3 goes into 27 9 times, 4 times 4 gives you 16. So you do this math, so it becomes 8 over 9 plus 16 over 9. And basically you want to get the common denominator. So the third one needs to be multiplied by 3, both top and bottom. It becomes plus 30 over 9. And the last one, 6, needs to multiply by 9. So it becomes 54 over 9. And all you need to do is just collect tops basically. So 8 plus 16, that would leave you with 24, plus 30 gives you 54, 54 minus 54, you end up getting just 0 over 9, that overall equals 0. So it verifies, so it basically says that implies, the implication is that 2 over 3 is gonna be the root of this polynomial, or in other words, if you like, 3x minus 2, this monomial, this linear polynomial, is a factor of this given polynomial. Alright, and by the way, I do have a bunch of different videos on polynomials for remainder theorem for solving cubic equations or a quoting coefficients approach. And if you are down to this videos, feel free, go ahead and check it out. Alright, with this being said, I hope it has been helpful to you. Huge thanks for watching, and in your brain, I know everyone hates math, but if you like my video, please hit this like, share with your friends, leave the comments down below, and be sure to smash that subscribe button if you haven't, so you will not miss out my new videos. Down below in the description box, go free.